Ngalakin kadijan nyunga boja.
Video 22. This video is about the special keyword null, which is a special word that means basically nothing or unknown. So the problem is that real life databases are often incomplete. There's always data missing, but you still have to make queries against those databases. And so there must be some mechanism for dealing consistently with missing data, or just values that are not yet known, or values that maybe will never be known. So SQL accomplishes this by having a special value null, which can be the value stored in a field of any type, a column of any type. And you should think of null as meaning something like the data that should be in this field is absent or unknown, or sometimes the data in this field would have no meaning. Probably the first way of thinking about it is the best to start with. So to deal with this, there is the special value null, and all of the SQL operators and functions behave in predictable special purpose ways when one of the arguments is null. Most of these ways are things that you could work out for yourself if you interpret null as meaning absent or unknown. Okay, here is a sample little mini database that we will use to sort of illustrate the use of null. I've just created a table called scores. It has two fields, A and B, both of type int, and I'm going to put some values into that table. Now, to insert a tuple into a table, we use insert into, and then the table name, then the word values, and then all of the tuples that you want to enter. So most of these tuples, or some of these tuples, are just normal, like 1, 3, 2, 4, but in some of them I've entered the special word null, which I just type NULL. Now, be very careful here. Null is not the string null. If you put the string null in there, then everything will behave differently. So null without any quotes around it. Okay, then just to check that everything's okay, I do select star from scores, and there's exactly the 5 tuples that I entered in there. 3 of the tuples are normal, one of them's got a null in the first column, one of them's got a null in the second column. Okay, operators. All of the normal arithmetic operators, plus, minus, and so on, well, if any part of that expression is null, then the final value is also null. That makes sense. If I'm asking, well, here I've said select A and B and then A plus B, so I'm adding the first 2 columns together. If A is 1 and B is 3, then certainly I know how to calculate C. 1 plus 3 equals 4. 2 plus 4 equals 6. But now in this third row, I've got unknown plus 4. Well, if something's unknown and I add 4 to it, well, then I still don't know it any better. So null is the only sensible thing that you can put for the sum of 2 things, one of which is null. And this carries through to all of the other arithmetic expressions. So basically, null simply destroys the meaning of any arithmetic expression, because if you don't know some value, well, then you don't know the value of any expression involving that value. Any normal comparison involving null will have the value null, which is sort of strange. So here, A equals null. So you probably can't see it in that color. Let me choose a better color. A equals null. Well, we're testing here, is A equal to null? Well, if A has a value like 4 or something like that, well then, of course, we can't tell because we don't know whether A is null. we don't know whether the unknown value is equal to 4. But this will fail even if A has the value null, which also makes sense. So you have to think about it a bit difficult, a bit harder. Okay, so if A happens to have the value null in a particular row, then we're testing whether it's equal to some other value that's also null. Well, just because two values are both unknown doesn't mean that they're the same unknown. And so, again, this expression will simply be false. Okay, we can't guarantee that A is equal to null, and so this query will produce no output. Unfortunately, this query also produces no output. Select star from scores where A is not equal to null. Well, the trouble is that even if A has some value, like 4, something like that, then we can't guarantee that it's not equal to the unknown value, because after all, the unknown value could be 4. So this expression fails or returns false whether or not A has a value or whether or not A is actually itself equal to null. So this has the interesting consequence that both of the expressions, A equals null and A is not equal to null, are always false. So these are always false, and it's because null isn't a fixed thing. It's just because null means sort of any possible value unknown at the moment. Okay, that's sort of slightly mind-bending. It gets worse. Well, before it gets worse, it gets better. We can check to see if the field actually does literally contain the special keyword null, but we can't use the equal sign for that because sort of that's reserved for comparisons of known values. And so there's a special keyword. The special keyword is null, and so that will actually check each value A to see the column A for each of the rows. It'll check A. If A is a value, like 3, 4, 5, then obviously it's not null, so it returns false. On the other hand, if A literally is equal to null, then that comparison will be true, and so it will print the that particular row out. So if I ask for all the scores where A is null, then I'll just get the one row of the table where A happens to be null. What about aggregate functions? Now, you might find this upsetting, but again, when you think about it, it does what it really should do, which is aggregate functions. They don't cause the result to be null, but they just pretend that the null values are not there. Okay, so that's sort of an interesting aspect of things. So let's select count of A. So when we count A, we have, well, how many rows are there in A? Well, there are 5 rows in A, 5 rows for under the column A, but one of them is null, and so that one is skipped, and it says that the count is 4. What about the sum of A? Well, the sum of A is 1 plus 2. Well, it should be plus null, but it doesn't do that. It just skips it. 1 plus 2 plus 3 plus 5. And it gives us the sum of all of those values. What about the average value? The average of A, well, it will do exactly the same thing. It will take the count, and then, well, take the sum of all of the things, only counting the ones that aren't null, and it will divide by the count of the number of entries, only counting the ones that aren't null. So when you think about it, this is actually what you want it to do, mostly. So suppose that A was some marks on some assignment or something, then what would null mean in that context? Well, probably what null would mean would be this paper hasn't been marked yet, this person's got an extension or something like that. Okay, so when we started to do calculate the average score on that assignment, we would actually want to only count 4 values, and we'd actually want to only divide by 4. So the aggregate functions, they will simply skip the null values and just pretend that they're not there, essentially. Okay, how does null behave with subqueries? Okay, so let's have this also is a bit strange until you think about it, and then it actually becomes sort of, oh yeah, I guess that's really how we should do things. Okay, so here's a select star from scores where A is in, and then select B from scores. Okay, so the subquery is run first, and all of the values that are the B values from that table are the result of the subquery. So let's see what this subquery will look like. What were the values in B? 3, 4, 4, 7 null. 3, 4, 4, 7 and null. Okay, and then the in operator will check for which values of A are in that set. Well, 3 is in that set, and so that's one of the rows that is accepted by that where condition. Okay, now that's fine. What about select star from scores where A is not in? So all I've done from the previous query is change in to not in. Okay, well, so now select B from scores is exactly the same as it was before. 3, 4, 4, 7 and null. Okay, and now it has to test for each A in turn. Is A not in this set? Well, the point is, it can never guarantee that any particular value of A is not in the set, because this null could be any value at all. It's just unknown. So we can't say that A is definitely not in that set, whereas for the value of A, when A was 3 and we were doing in that set, then we could definitely tell that 3 was in the set because the null didn't affect things, but we can't check that A is not in that set because the null in that position is sort of causing us uncertainty about whether a particular value is or is not in that set. Okay, so if you really did want to say where A is not in, and then you wanted to check whether it was not in the non-null values in B, you would have to change your query, select B from scores where B is not null, and then that subquery will now do sort of what you might expect it to do. Okay. We've seen a variety of joins, and all of the joins that we've seen so far are what are called inner joins, and what I want to talk about now are outer joins. And the reason that I'm talking about it now instead of when we talked about joins is because outer joins and null fundamentally go together. Okay, so just to recall, if you get a table T that you've obtained by joining table T1, which has got 3 columns, A, B, and C, to table T2, which has got 3 columns, D, E, F, then the resulting table after this join will have schema, will be called T, and have schema A, B, C, D, E, F. For any row of this joined table must consist of, so the new table that we've just created by joining will have columns A, B, C, and D, E, F, and any row of this new table must consist of, the first three things must be some row from T1, and the second three things must be some row from T2. Okay, what happens if there's a row of T1 that doesn't pair up with any rows of T2? Like there's nothing, like, I mean, it doesn't matter what the join condition is. It might be something like C equals D, in which case, you know, the green tuple would only match up with a purple tuple if the green value of C matched the purple value of D. But what happens if a row of T1 doesn't satisfy the join condition? There are no rows of T2 with the right value of C. So in that case, well, T1 just, that particular row of T1 just doesn't appear in the joined table. Okay? Often that's what we want, and so that's fine, but sometimes that's not what we want, and in order to get around that, that is the purpose of an outer join. Okay, let's look at a little silly schema. So I've got some students. I've got 6 students: Amy, Bill, Chin, Dagmar, and Engguan. Okay, so, well, sorry, 5 students. Amy, Bill, Chin, Dagmar, Engguan, 5 students. I've got 6 units: programming, databases, chemistry, physics, maths 1 and maths 2. They're in my unit table. So again, this is sort of the students enrolled in units example. And then I've got my enrollment table. I've got student number 1, that's Amy, did math 1001 in 2018 and passed. And so student Amy is now doing math 1002, it's 2019, and she passed. Bill, on the other hand, failed CITS1402 in 2019, he only got 30, and he's trying it again this year, 2020. Okay, so what we'll notice, or what you should notice, is that Chin, student number 3, Dagmar, student number 4, and Engguan, student number 5, are not yet enrolled in anything. They're in the list of students, but they have no current enrollments at the moment. Okay, does that mean that we always want to ignore Chin and Dagmar and Engguan? Or does it mean that in some circumstances we still want to keep information about them, even if that information is just they're not enrolled in anything? Let's see. If I just do a plain inner join, select star from student S, join enrollment E on s.snum equals e.snum. So I'm just joining on the 2 snum columns. Then I will only get the enrollments. All this is actually doing is taking each tuple from the enrollment table. Here's a tuple from the enrollment table. And it's just gluing on the name of the student, which I've extracted from the student table. And the join condition is there to ensure that this is student number 1, so this name belongs to student number 1, and this enrollment is relating to student number 1. So it just means that the 2 halves of each row, well, they're not exactly halves, the 2 parts of each row refer to the same student. Okay, so Amy's got 2 enrollments listed, Bill's got 2 enrollments listed, one of them incomplete, but the other 3 students do not appear at all. Now, let's see what happens when I replace join by this special phrase, left join. Okay, now what happens when I replace join by left join is I get all the things that I previously got, all of the things that were like composed of a row of student paired up with a row of enrollment chosen so that they only relate to the same student. But now I get extra things here. I've got 3 additional rows. Each of those 3 additional rows consists of the part from student that would be there if it matched anything, and a whole bunch of nulls. A whole bunch of nulls, a whole bunch of nulls, a whole bunch of nulls. Okay, so this table, I mean, at first sight, it seems to be not super useful because it's got like full enrollment information about people who are enrolled in things or have been enrolled in things, and it's just got the names for the other people, and then those rows have been sort of padded out with nulls just to fit, just because we know how many columns each row needs, and so it's just put enough nulls in there to fill out those columns. Okay, so what is the rule then? So in a left join, every row in the first named table, which I'm going to call the left table, so that one, every row in the left table appears at least once, even if it doesn't match any of the right table rows. If a left table row, like to Bill, does match up with a right table row, so this is from the first student, that's from student, this is from enrollment, they match because they've both got 2 for the student number field. If a left table row matches a right table row, then it just appears as usual. So nothing is different for the rows of the left table that do match. If a left table row doesn't satisfy the join condition with any of the right table rows, so in other words, it would vanish unless we do something about it, well, then we just create a dummy right-hand row consisting of null, 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 and then plonk that tuple into the resulting joined table. Okay, so why is it useful to do this? Well, the reason is that it is useful to know that somebody is a student but hasn't yet enrolled in anything. So, so the way that we can most easily sort of make productive use of this is by using the fact that the aggregate functions skip nulls. So if I do select sname, so that's the name of the student, and I'm going to count ucode. So that's going to keep a count of the ucode field. I'm going to do the left join as just described, and then group by s.snum. Okay, so I'm going to do a group by student number, and then I'm going to count by unit code. Okay, so in the first group is the group of student number 1, so that's Amy. There are 2 rows in that group. If I count ucode, I count these 2 values, math1001, math1002. Doesn't matter what the values are because I'm just counting how many rows there are, and that will give me 2. So that tells me that Amy has 2 enrollments altogether. The group consisting of Bill, well, that's also got 2 enrollments. So count those, that's 2. Now 3 is another student number. So Chin forms a group all on his own, her own. And I'm going to count the unit code table, well, the unit code field, okay, so there's one row, but the value in that one row is null, and so that means that the count is 0. So this now tells me that Chin has 0 enrollments. Well, that actually is exactly what we want. In this case, we want to know that Amy has 2 enrollments, Bill has 2, Chin has 0 enrollments. So this is the sort of thing that might be useful when you're sort of sending reminder letters out to students, because it would indicate that the student has connected to the system, but they haven't created any enrollments. So you might send them a reminder letter. So the use of the outer join, the left join, is is pretty much so that when you do summary data, you can actually include the zeros in your counts. So that's probably the most important use for the left joins. You'll notice here I've put left outer join here instead of just left join. Well, as I've said before, SQL normally has many ways to do things, and often they're the same as each other. And so left join and left outer join are actually synonyms for each other. You can use either of them and they just do the same thing. So here's an example relating to the classic models database. What I'm wanting to do is to count how many staff the E1 person supervises. Okay, so if you unpack what this sentence does, it forms groups according to employee number E1. So E1 is one copy of the table employees. E2 is another copy of the table E2. E2 is another copy of the table employees. We're going to join E1 and E2 according to this result. According to this condition, E1 employee number must equal E2.reports2. Well, that means that E1 is the supervisor of E2. So every row in this this join table is going to reflect a supervision relationship where E1 supervises E2. That means if I count the number of times, if I count the number of distinct reports to rows, that will tell me how many people E1, this particular employee, supervises. And so that's the number that's going to be produced. This won't count anyone if they don't supervise anyone, because they will simply not appear in the join. The join condition ensures that the only time a row appears in the joined table is when the employee in the row of E1, the relevant row of E1, supervises the employee of the relevant row of E2. If there are no supervisions happening, then that row just doesn't exist. So here we just changed the join to a left join, and now all of the employees who don't supervise anyone still appear in this table, but just instead of the sort of part of the row that shows who they supervise, there's just a bunch of nulls there. So once we count those things, then it will correctly count 0 for the number of people who don't supervise anyone. Okay, a few final remarks. Left outer join is the same as left join. In SQL, you also have a right join and right outer join. So what that does is, if there are any rows in the right-hand table that don't match anything in the left-hand table, then it creates a special row with the left-hand part padded out with nulls and the right-hand part coming from the the right table. You might want to, I'm sure you can imagine a situation where you want to combine both the left outer join and the right outer join so that all sort of lonely rows, whether they're a left table row with no matching right table row or a right table row with no matching left table row, should appear with the sort of missing parts padded out with nulls. Well, you obtain this by full join in SQL, full outer join in SQL. None of these are implemented in SQLite. If you want to do these sorts of things in SQLite, well, you have to do something different. You have to sort of work around these limitations. It's not an incredibly difficult to work around these. So usually, most situations, you only want a one-way join anyway. You don't usually want both the left and the right join. And obviously, if SQLite has supplied you a left join, then you can simply arrange that the relevant table is on the left of your join condition. Okay, so that's all for null and all for the outer joins, which is one of the main purposes of, well, one of the main beneficiaries of the behavior of null.